Good morning, Grammar 6. Hope you guys are doing really well. Today we're going to talk about corresponding parts and similar triangles. Just the basis for looking at right triangles and similar triangles. It's a pretty, important skill, and hopefully, I know you guys are going to rock it. So hopefully you guys have done your facts practice, your mental math warm-up, and then let's talk about corresponding parts. Well, corresponding parts of a triangle, particularly when they are congruent, means that the angles and sides are the same. So if you look at triangle ABC, and you look at triangle XYZ, they look pretty similar. And if we wanted to prove that they were congruent, we could go through a set of transformations by rotating the triangle ABC, by translating, which is the same as sliding, and then reflecting triangle ABC, which is the same as flipping triangle ABC. You would be placing triangle ABC right on top of triangle XYZ, and you would see that their corresponding parts would be together. And what that means is angle A right here corresponds to angle X. Angle B right here corresponds to angle Y. And then we can see very easily angle C corresponds to angle Z. And it's the same for side lengths of a triangle. So we have AB would correspond to XY. This is called the hypotenuse. It's the side opposite the right triangle. BC, which is right here, it's a leg of the right triangle, corresponds to YZ, right here. And AC, another leg of the triangle, would correspond to XZ right here. So if these two figures are congruent, then their corresponding parts are congruent as well, and that would mean that the measures of the corresponding parts are equal. So if you look at example 1, it says these triangles are congruent. What is the perimeter of each? We know that the perimeter is the measurement all around an object. Here we have, in this first triangle, we have the legs are 3 and 4 inches, but in this triangle, we have the leg is 4 inches and the hypotenuse is 5 inches. We know that these triangles are congruent, so we can assume that this hypotenuse on this triangle is 5. If you add up each of the sides, 3 plus 4 is 7, plus 5 is 12. You could also conversely say this is 4 inches and this is 3 inches. So 4 plus 3 is 7, 7 plus 5 is 12 inches. So moving on, similar figures, similar triangles are figures that are the same shape, but not necessarily the same size. And what that means is we look here, and if you look at these 4 triangles, we see some commonalities. One, we see that 3 of them are right triangles. Triangle 4 looks like an equilateral triangle, which really wouldn't mesh with these guys. If I look at triangles 1 and 2, they look like they are the same shape, maybe a little smaller size in triangle 2. Triangle 3 is also similar, it's just a little larger. So we could say that triangles 1, 2, and 3 are similar, but not triangle 4. All right, so let's look at example 2. It says the 2 triangles are similar. What is the measure of angle A? Well, here we need to really rely on our transformations. So in order for us to find out what the measurement of angle A is, we're going to rotate and reflect triangle A, B, and C so that the corresponding angles are easier to see. And so what we're going to do here is we are going to rotate triangle ABC up, and then we are going to flip it over so that we have AC lined up with this side right here. Angle B is right here, and angle A is right here. So we know that since these are similar triangles, angle A is going to be the same measurement as this angle right here. So we're going to say angle A is 30 degrees. So go ahead and do your practice. Make sure you answer these. These are really important questions to write out in full sentences, and then do your problem set. Okay, hope you guys are doing awesome. I will see you tomorrow for lesson 110, and that is that. All right, bye guys.